In this video, I'll go over Test 2 from Math 138, Spring 2013. Problem 1, differentiate the following. Y is equal to x squared times sine of 3x. In order to find the derivative, we need to use the product rule. So it's going to be the derivative of x squared is 2x multiplied by sine of 3x plus the derivative of sine of 3x. That requires chain rule. So it's cosine of 3x times 3 because the derivative of 3x is 3. And then to finish product rule, we multiply by x squared. And then just reorganize a little bit your answer. So you have 2x times sine of 3x plus 3x squared cosine of 3x is equal to the derivative. B, f of x is equal to cosine of x divided by 4x. We need to use the quotient rule. So derivative of f is equal to the derivative of cosine of x is negative sine of x times 4x minus the derivative of 4x is 4 times cosine of x divided by the denominator squared. So 4x squared is 16x squared. And then notice that you can simplify 4 and 4 in the denominator. So the answer to the derivative is negative x times sine of x minus cosine of x divided by 4x squared. C, g of x is equal to 3 times natural log of x to the 5th minus 4x plus 1 is plus 7e to the 2x. So the derivative of function g is 3 times. Now the derivative of natural log of x to the 5th minus 4x plus 1 is 1 over the argument, so 1 over x squared minus 4x plus 1 multiplied by the derivative of the argument. So the derivative of x to the 5th minus 4x plus 1 is 5x to the 4th minus 4. And I just put that in the numerator. And then the derivative of 7e to the 2x is 7 times chain rule, e to the 2x times the derivative of 2x, which is 2. And then to simplify, I multiplied 3 in the numerator here. So I get 15x to the 4th minus 12 in the numerator, divided by x to the 5th minus 4x plus 1 plus, and you multiply 7 and 2, so you get 14e to the 2x. D, function h of t is equal to e to the t times natural log of 5t, product rule again. H prime of t is equal to the derivative of e to the t is e to the t multiplied by natural log of 5t plus the derivative of natural log of 5t is going to be 1 over 5t multiplied by the derivative of 5t, which is 5, and I just put it in the numerator. To finish product rule, you multiply it by this function e to the t. And then you can simplify 5 and 5 here. So the answer is e to the t times natural log of 5t plus e to the t over t. You could also factor out e to the t, so it's e to the t times natural log of 5t plus 1 over t. E, y is equal to tangent of natural log of x. That requires chain rule. So the derivative, the outer function is tangent of the argument. So the derivative of tangent is secant of argument squared times, and now by the chain rule you have to multiply by the derivative of natural log of x. The derivative of natural log of x is 1 over x. So this is your answer, or you can write it with x in the denominator like this. F, y is equal to the square root of e to the x times tangent of x. So I rewrite my function so that I don't see that square root, so the square root becomes a power of 1/2. And then the derivative requires chain rule, of course, so the outer function is argument to the 1/2. So the derivative of that is going to be 1/2 times the argument to the negative 1/2. And then by the chain rule, I have to multiply by the derivative of this argument, e to the x times tangent of x. And the derivative here requires the product rule. So we have the derivative of e to the x is e to the x multiplied by tangent of x plus the derivative of tangent of x is secant of x squared multiplied by e to the x. And that's the derivative over here. Problem 2. First write the given logarithmic function in expanded form, then find its derivative. So if you expand this logarithmic function, you'll end up with 2 natural log of x, because that 2 comes down, plus 1/2. 1/2 used to be the power of sine of 3x. So it's going to be 1/2 natural log of sine of 3x minus natural log, minus because it's division, natural log of x cubed plus 1. And then once you have this expanded form, you find the derivative. So derivative of function f is going to be 2 times derivative of natural log of x is 1 over x, so it's 2 over x, plus 1/2 times, now the derivative of natural log of sine of 3x requires chain rule, so it's going to be 1 over the argument, so it's 1 over sine of 3x, times the derivative of sine of 3x, another chain rule, cosine of 3x, times 3, because the derivative of 3x is 3. So that's the derivative. This part is the derivative of 1/2 natural log of sine of 3x. And then minus the derivative of this last term is 1 over the argument, so 1 over x cubed plus 1, multiplied by the derivative of the argument itself. So the derivative of 3x of x cubed plus 1 is 3x squared. And then just simplify it a little bit, organize it. So I organize it into 2 over x plus 3 over 2 times cosine of 3x over sine of 3x minus 3x squared over x cubed plus 1. You could also change this cosine of 3x over sine of 3x into cotangent of 3x, but it wasn't required. Problem 3. Use implicit differentiation to find dy dx. Now the derivative of sine of 2x with respect to x is going to be cosine of 2x times 2 by the chain rule. So the derivative of the outer function, sine of argument, is cosine of the same argument, multiplied by 2 because the derivative of 2x is 2, plus the derivative of e to the y is e to the y times y prime, because the derivative has to be found with respect to x, not with respect to y, so chain rule here. And the derivative of 4 on the other side is 0. And then you just solve this equation for y prime. Or if you use the notation dy dx, it would be dy dx over here. So you move this part over to the other side and divide both sides by e to the y. So you have y prime is equal to negative times negative 2 cosine of 2x divided by e to the y. In part B, again implicit differentiation, same instructions. So the derivative of x squared y cubed requires a product rule. So we have the derivative of x squared is 2x times y cubed plus x squared, I just put it in front, you can put it in the back if you want, times the derivative of y cubed. The derivative of y cubed would be 3y squared alone, but we're finding the derivative with respect to x, so we need to use the chain rule. So now the derivative of the inner function y is y prime. Then you have plus y squared. The derivative of y squared is going to be 2y times y prime, again chain rule. Remember, we're finding the derivative with respect to x, not y. So that's why we need to use the chain rule here. And the derivative of 5 on the other side is 0. Now we solve this equation for y prime, or dy dx if you use that notation. So I factor out y prime from these two terms that I've underlined here, and I move the first term over to the other side. And then divide both sides by this expression here that's multiplied by y prime. So y prime is equal to negative 2x y cubed divided by this whole thing, which is 3x squared y squared plus 2y. Problem 4. Find the equation of a line tangent to the graph of natural log of y minus 2x squared is equal to negative 8 at point negative 2, 1. In order to find the derivative of function y, I need to use implicit differentiation here. So the derivative of natural log of y is 1 over y times the derivative of the inner function, so y prime, minus the derivative of 2x squared is 4x, and the derivative of negative 8 is 0. And then you solve this equation for y prime. So bring 4x over, and multiply both sides by y. So you have y prime is equal to 4xy. This is the derivative of y with respect to x. Now, you evaluate this derivative at the given point -2, 1. So you plug -2 in for x here, and 1 in for y, and you get that the slope of the line tangent to the graph is 4 times -2 times 1, which is -8. And then you use the point slope form of the line or some other method to get the equation of the line. So you have y minus the y coordinate of the point is equal to the slope times x minus the x coordinate of the point, so it's x minus -2. And you just solve it for y to get the slope intercept form.